Hello! Hi! Wave, wave, wave! Hi! I'm Dowy Tagud, and I will be your statistics teacher for today. And we're here in descriptive statistics and hope that you will be enjoying our lesson. Okay? So, let's go! Alright guys, before we're going to proceed to our lesson, I'll be reading to you the COVID precaution. Protect yourself and others around you by knowing the facts and taking appropriate precautions. Follow advice provided by your local health authority. To prevent the spread of COVID-19, clean your hands often, okay? Use soap and water or an alcohol-based hand rub. Maintain a safe distance from anyone who is coughing or sneezing. Achoo! Wear mask when physical distancing is not possible. Do not touch your eyes, nose, or mouth. Cover your nose and mouth with your bent elbows like this. Or tissue paper when you cough or sneeze, okay? And stay at home if you feel unwell. And if you have a fever, cough, and difficulty in breathing, seek medical attention. Calling in advance allows your healthcare providers to quickly direct you to the right health facility. This protects you and prevents the spread of viruses and other infections. Well, talking about masks, mask can help you prevent spread the virus from the person wearing the mask to others. However, masks alone do not protect against COVID-19 and should be combined with physical distancing, hand hygiene, and you have to follow the advice provided by your local health authority. Well, in the end of this lesson, you'll be able to describe the terms used in statistics. You'll be able to organize data in frequency distribution and graphs. And, of course, you'll be able to interpret data in terms of kurtosis and skewness. When we're talking about statistics, what comes up in your mind? Well, anyway, guys, statistics, it is a collection of data associated with human enterprises, right? But anyway, guys, I'm going to show you a video, and I want you to pay attention to this video because you'll be answering our exercises, okay? We have a lot of exercises to do, okay? So, there it is.
What is statistics? Well, it is the science of collecting, organizing, summarizing, and interpreting data. For instance, according to the U.S. Department of Health and Human Services website, less than 5% of adults participate in 30 minutes of physical activity each day. Children spend more than 7.5 hours a day in front of a screen. And for 2 to 18-year-olds, 40% of their total daily calories come from added sugars and solid fats. All of these numbers come from data and statistical analysis of this data. And what statistics actually does is gives us, people, a way to make informed decisions. For example, if you've ever bought something on Amazon, you probably look at the star ratings. If you find two similar versions of a product you want, say a camera lens, you look at the price of each, then how many overall stars it has, then maybe the distribution of the ratings, and how many total ratings it has, and maybe read a few of the highest and lowest reviews about the lens. Then you're going to look at the sellers of the lens and check out their ratings, and then you check out the delivery time till you have the product in your hands. In this scenario, you would have done a very quick and informal statistical analysis. In learning about statistics, there are some important terms to have a basic understanding of. An individual, also called an element, is a person or object included in a study. Variable is characteristic of the individual being measured or observed, which varies from individual to individual. So for instance, this could be occupation, income, age, or education. Observation is a value that is observed for a variable. which is also called a measurement. And a person can actually be an observation, as can a certain product or even a set period in time. Data is a piece of information or pieces of information, or the values or measurements of a variable collected on individuals. All of these would be observations for each of the different variables. Data set is a collection of data, so this table lists the individuals, the variables, and each of the observations for each of the individuals. This little table here would be considered a data set.
There you go. Wow. Okay, so nice viewing, guys. So here's our exercise number 1. Are you ready right there? Are you ready? Come on. Okay, guys, you're going to answer these questions. And of course, you're going to what? Okay, will you please grab your modules, or did you have your worksheets already? Okay, I want you to answer these questions using your modules or your worksheets provided by the teachers, okay? So I want you to answer the following questions. Well, you can answer right there in your modules or your worksheets, okay? So I'm going to read the question number 1. What can you say about the video? You just have to write it right there, okay? Number 2, is statistics important in your life as a student? Let's see. Okay, guys, we're here now in exercise number 2. As you can see, there's a table right there. And it is the world population. Okay, there's a year, in the first column is the year, and the second column is the population. In the year 1800, the population of the world is 1 billion. And in 1900, it reached 2 billion. In the year 2000, it became 6 billion. And in the year 2015, it reached 7 billion. Okay, now, here's some question. What can you say about the table? You have to explain it to your worksheet, okay? All right. And as you can see, guys, question number 2. What have you noticed about the number of populations? Why it turned to be like that? Well, you can write your answer, explain your answers right there briefly, okay? Right, and then next question. What might have happened from 1900 to year 2000? So, let's think about it. Let's try to analyze the data. Okay, here in table 2, okay, it is a distribution of people in 2015. The first column is the continent, the second column is 2015, and the third column is 2100. Let's check it out. In America, the distribution of people in 2015 is less than 1 billion. And in 2000 or in 2100, it becomes 1 billion. And in Europe, it's less than 1 billion. But in 2100, it becomes 1 billion. In Africa, the distribution of people in 2015 is less than 1 billion. And it becomes 4 billion in 2100. So in Asia, The distribution of people in 2015 was negative or less than 4 billion. But in 2100, it becomes 4 billion. Okay, here's the questions. What can you say about the table? Next, what have you noticed about the number of people distributed in the continents? Try to think about it, guys. I want you to analyze the data. Don't you know, guys, that we have 3 types of statistical methodology? Number 1 is descriptive statistics. It gives us information or describes the sample we are studying. The example is mean percentage. Number 2 is correlational statistics. It gives us the relationship between variables. It tells us the degree of association of 2 or more variables. Example, Spearman-Rowe and Pearson R product. Number 3 is inferential statistics. It gives us inference about the population based on the averages of variability of sample. Example for that is ANOVA. Well, guys, we have 2 types of data. Number 1 is continuous data. Data that contains fractions, for example, height, weight, and others, okay? Number 2 is discrete data. It refers to integral numbers only, like men, barangay, and others. Well, for further explanation, I'll be playing another video, okay? Guys, I want you to pay attention with the video because you will be getting a lot of information, okay? That you really need for you to answer the questions later. It will really help you. So, let's go!
Today we will define what it means for data to be either continuous or discrete, and we will offer some examples of each. We say that a set of data is continuous if the values belonging to the set can take any value within a finite or infinite interval. While on the other hand, a set of data is considered discrete if the values of the set are distinct and separate, or in other words, the data can only take certain values. Another way to think about this is to consider that continuous data is data that can be measured, while discrete data is data that can be counted. These concepts make a little more sense when we consider some examples. Consider the height of a sunflower grown from a seed that is supposed to reach 6 feet or 70 inches tall. We can measure how tall the sunflower is, and we say that the height is anywhere from 0 to 70 inches. We know that the height, therefore, can take any value on the interval from 0 to 70. Now let's say you're playing dice. With one roll, you will have either 1, 2, 3, 4, 5, or 6. And unlike continuous data, discrete data cannot be on an interval, which makes sense because you can't roll 2.5. In this case, we have 6 distinct values for our 6 different outcomes. Let's take a look at a couple more examples for continuous and discrete data. Like we mentioned earlier, continuous data can be measured, like the height of a child, or the length of a leaf, or the speed of a train. These measurable things can all fall on a continuous interval. Some examples of discrete data include the number of languages that somebody speaks, the numbers of books on a bookshelf, or the number of people in a family, all of which can be counted. With this lesson, you should now have a better understanding of discrete and continuous data sets and examples of each.
Alright, so how's the video, guys? I hope it will really help you with this, okay? So, let's continue our discussion. Okay, so I'll be discussing to you about the types of measurement scales. Number 1 is nominal scale. Nominal scale measures the identity or measures of identity. Numbers may serve as labels to identify the items or classes. For example, numbers attached on the athletes. Okay? Simple statistics are used with nominal data like frequency, proportion, and percentages. Second is ordinal scale. Number that reflect the rank order of the individuals. Ordinal measures are arranged from highest to lowest or vice versa. Example, Spearman row is used with this data. Number 3 is interval data. It provides numbers that reflect differences among items. For example, test scores, temperature reading, and others. Most statistical computations use interval data like mean, standard deviation, Pearson R, and others. Number 4 is ratio scale. It is the highest type of scale. The basic differences between this type and interval data is the ratio scale have absolute zero. Example, measure of length, height, loudness, speed, and others. And for further explanation, I'm going to play another video again. Okay, it's all about the scales of measurement. So, take a look at this.
In psychology, there are a number of ways of measuring things. The scales we choose depends on the information that the data is intending to represent. There are 4 scales of measurement. These are nominal, ordinal, interval, and ratio scales. Understanding the difference between these and being able to identify which is which is important, since it will guide you in selecting the statistics you want to use to analyse your data. So first we have the nominal scale. As the name implies, it's simply about placing data into categories without any order or structure. The category can be expressed in a numeric code or a non-numeric label. So for example, if a university wants to classify its students into groups based on their major, they can express the information by labelling the groups with their respective major names. They could also give the groups a numeric label, such as 1 for health, 2 for business, and so on. Likewise, if you were to conduct a survey asking a question and the answer is yes or no, then this too would be a nominal scale because there is no order and there is no distance between yes and no. Statistics used with nominal scales are in the non-parametric group and would include the mode cross-tabulation with chi-square. Next we have the ordinal scale. This one is used when you want to classify information based on a specific order or rank. Like nominal data, the information can be expressed either in a numeric or a non-numeric way. So for example, if a market researcher asks you to rank 5 colours in your order of preference from most favourite to least favourite, then he is asking you to create an ordinal scale of preference. The key here is that there is no objective distance between any 2 points. It is subjective. So an ordinal scale lets you interpret gross order but not the relative positional distances. Statistics used with ordinal data would be non-parametric and include median and mode, rank order correlation, and non-parametric analysis of variance. Next we have the interval measurement scale. This scale is used for numeric data that is expressed in interval of some kind of fixed measurement. In psychology, Likert scales are often used to collect data. Here people would be asked to indicate their agreement with a statement on a 5-point scale. Now this means that we can interpret differences in the distance along the scale. Statistics used for interval scales would be parametric statistic techniques, including mean and standard deviation, correlation, regression, analysis of variance, factor analysis, and a range of other advanced multivariate and modelling techniques. Non-parametric techniques could also be used, but these are less powerful than the parametric ones. And finally, we have the ratio scale, which is used to express the ratio of some kind of value of the interval data. This type of measurement is the most precise and most powerful, but it is not often available in social research. The factor that clearly defines the ratio scale is that it has a true 0 point. And the 0 point is meaningful because it means the absence of whatever it is that you are measuring. And it also means that you cannot have a negative point on a ratio scale. So for example, measuring something with a ruler would give you a measure in a ratio scale. 0 literally means no length. It doesn't exist. It also has characteristics of the interval scale in that something that is 2 inches long is half the length of something that is 4 inches long. But because of its 0 point, it is a ratio rather than an interval scale. Note that measures of temperature, centigrades and Fahrenheit, although they may look like ratio scales, are actually interval scales because they do not have a true 0 point. The statistics used with this type of data would be the same as those used for interval data.
Okay, this time, guys, hold your breath. I want you to grab a pen and paper handy because you will be needing those things to our next activity. Okay? I want you to get ready. Let's go. Okay, welcome here in organizing data. Ooh. Oh my God. Don't be scared about the numbers. Don't you worry, guys. I'll be helping you how to do the task later. But I just have to explain it to you step by step. Okay? Don't be afraid or don't be intimidated with the numbers. But anyway, the following is a set of scores on geography test. The highest possible score is 90. Well, as you can see, there's a lot of numbers right there. Okay, and the task that we'll be doing later, we're going to construct a frequency distribution table. Oh, do you have any idea? About that? Well, don't you worry. I'll be explaining it. I'll be showing it to you, okay? Don't be scared. Just take it easy. You'll be loving mathematics. Okay, and the next task is we'll be making a frequency polygon using the Excel. Okay, I'll be also teaching you how to make a graph using the Microsoft Excel. Are you excited or scared? Don't be scared. Okay, let's just have fun, okay? Let's do it. All right, guys. This is what the frequency distribution table looks like, okay? Oh, what is that? You're scratching your head already. Okay, just relax. Okay, let's take it easy. Okay, first thing that we have to do, we just have to get the range. Okay, we have to get the range, and to get the range, we have to subtract the lowest score from the highest score. Okay, so as you can see, there's a lot of numbers right there, and it is ungrouped. And I'll be giving you the formula to get the range, okay? Range is equals to highest score minus the lowest score. As you can see, our lowest score right there is 28, right? Okay, I circled it with a red circle. Okay, and the highest score right there is 82. That's the highest score, right? So the lowest score is 28 and the highest score is 82. Now, let's subtract it, okay? So 82 minus 28 equals 54. So the range is 54. Very good. Okay then, are you still there? Okay, so next step. You have to determine the class interval or CI by dividing range plus 1 by arbitrary number between 6 to 15. Okay, this time we're going to use 6 when the class size is small, from 20 to 30, or let's just say less than 40. So we'll be using 6. And you can use 15 when the class size is large, like 100 and up. Okay? So look at the example. Okay, so here's the formula. Okay, so class interval equals R. Okay, that is what? The range plus 1 over 6. Note, we use 6 because it is less than 40. Okay, so let's continue. So the range is 54, 54 plus 1. So it becomes 55 over 6. So it is equals 9.16. Or we just have to take it as 9. Did you get it? Okay, there you go. Thank you. Okay, next. So this time we're going to write the limits of each step or class starting at the bottom with the lower limit less than or equal to the lowest score. Okay, look at the example, guys. Don't get lost. Okay, pay attention right here. Okay, so as you can see, our class interval is 9, right? Remember? Okay, we're going to start with the lower limit. Okay, example, the class interval is 9, so 9 plus 9 is 18. Another 9 is 27, and plus 9 is 36. Okay, remember guys, the lowest score is 28. So, where do you think the 28 belongs? Okay, which interval? It belongs to 27. Okay, so right here, we're going to start with 27. Okay, look at the class interval. Okay, as you can see, the class interval, it might be confusing, but don't get confused, okay? All right, I'll be explaining it to you one by one. Okay, so the first number that we have to put right here is 27. And remember, the class interval is 9. So here's what we're gonna do. 27. Okay, 27. Here's the technique. Okay, 27. 27, 28, 29, 30. 31, 32, 33, 34, 35. So the first interval is 27 to 35. Okay? Did you get it? Okay. The second interval, we have, look at the bottom, okay? Don't get lost. Just look at the bottom because we are starting right there. Okay? Okay, so next interval is 36 to 44. Why is it 36 to 44? Okay, you're done with the 35. So let's start with 36. Okay, let's do it again. 36, 37, 38, 39, 40. 41, 42, 43, 44. Okay, so that is why it is 36 to 44. Okay, next interval. We are done with the 44, so let's start with 45. Okay, 45, 46, 47, 48, 49, 50, 51, 52, 53. Did you get it now? Okay? I hope it's already clear to you. Okay, let's do it slowly. Another one. We're done with the 53. So let's go to 54. 54, 55, 56, 57, 58, 59, 60, 61, 62. Okay, we're done with 62. It's 63, 64, 63, 64, 65, 66, 67, 68, 69, 70, 71. We're done with the 71. Let's start with the 72. 72, 73, 74, 75, 76, 77, 78, 79, 80. We're done with the 80, so let's start with 81. 81, 89, 81, 82, 83, 84, 85, 86, 87, 88, 89. So our interval is complete. Since the highest score is 82, there's no need for you to proceed to the higher number because we're just we just have to stop until the last interval from 81 to 89. Okay, guys. Since that we're done doing the interval, okay, I already teach you how to group the data. Okay, so here's what it looks like right now. I just transferred the data from the last slide to this slide. Okay, did you get it? Very good. Alright guys, since that we're done doing the class interval, I just transferred the data from the other slide to this slide. And now we'll be doing the second column, which is the tally. Okay, I want you to look at the video. Anyway, I'll be presenting a video for you to look at it or to try to learn from the video how to tally the scores. Okay, so get ready. Okay guys, here's how to tally the scores. I just transferred it in a piece of paper so that I can demonstrate it to you clearly and thoroughly. Okay, so we just have to look at the ungrouped data. Okay, this time it's already grouped now, okay, because I ordered it or I arrange it by interval. So the first number or the first score that we got right there is 56. Okay, so let us check where 56 belongs. Okay, so 56, I think it belongs right here. 56. Okay, so let me just put one right here. 56. Next is 78. So 78, I think 78 belongs right here. Next is 62. 62, still right here. Okay. Next is 37. 37. It belongs right here. Next is 54. 54, it belongs here. Next is 39. 39. 39, I think it belongs right here. 39, next is 62. Another 62. Another one is 60. Still right here. Okay, so next is 28. 28 is right here. 28, next is 82. 82. And then next is 38. Another 38 should be right here. 72 should be right here. 62. 62. Okay. Another is 44. Okay, 44. It belongs right here. Okay, so 54. Another 54 right here. 42. 42. 42. Should be right here. Another 42. 42. 55. 55 should be right here. 57. Still right here. 65. 65 should be right here. um 68. 68. Yeah, it should be right here. 47. 47. Should be right here. Okay, guys, we have to keep on doing this, okay, until we're finished putting all the scores, or putting all the scores where it belongs. Okay? Okay? All right. Okay, guys, take a look at this. Now we're done with the second column. I just transferred the data to the second column. Okay, I'm done with the tally, and it looks like this. Okay, this time, guys, we're going to write the frequencies of each step in the third column. Okay, there we go. We just have to add the frequencies and enter the sum at the bottom mark in. Okay, the first interval, we can start on the top. Okay, so oh guys, before I forget, please use your calculator. Okay, it'll be better if you'll be using a scientific calculator. Okay, guys, here's how you're going to get the cumulative frequency. First, you have to start with the sum, or the total number of frequencies, which is 38. Okay, so here's what you're gonna do. Okay, so it should start from 38. 38 minus 1 is 37. As you can see right there, I put it right there on your screen, okay? Okay, so 37 minus 2 equals 35. So you just have to put it right there on the third row from the top. Okay, so 35 minus 4, it turned 31. 31 minus 12, it's now 19. 19 minus 10, it turned 9. And now 9 minus 8 equals 1. And 1 minus 1 is 0. Now, making sure that the very bottom of it is 0. It means that you computed it correctly. Did you get it now? That's great. Okay. Next step. Write the relative frequency in the fifth column of the table. Okay, look at the bottom. Look at the bottom. Come on. Okay, as you can see, we have an example right there. RF, which is relative frequency. Okay, relative frequency is equals to frequency over, or divided by, the number of frequency, or total number of frequency rather. Okay, so in interval 84 to 89, the frequency is 1, right? So we have to divide it with 38. So it is equals 0.026. All right? Did you get it? Are you still following me, guys? Use your calculators. Okay? All right. All right, there we go. We're now in the relative frequency page. Okay, guys, just like what I've explained earlier, you just have to divide the frequency and the total number of frequencies. Okay, so the first row, 1 divided by 38, that is why it turned to be 0.026. Okay, 2 over 38, that is 0.053. 4 over 38, that is 0.105. 12 over 38, that is 0.316. 10 over 38, that is 0.263. And then 8 over 38, that is 0.211. And 1 over 38, it's 0.026. Okay, guys, this time you have to write the angle sector in the sixth column. How to do that? I'll be giving you an example. Look at the bottom. Okay, there's a computation in the bottom. Okay, look at it. Are you still following me? Okay, look at it. Okay, there's an example right there. RF, or what we called relative frequency, times 360 degrees. Okay. Okay, let's do it one by one. Okay, let's look at the fifth and sixth column. Okay, so the first, in the fifth column, in the first row, okay, we have there 0.026, okay, times 360. That is why it turned 9 degrees. Okay, so the second row, 0.053 times 360 degrees, it is equals to 19 degrees. Same as with the 0.105 times 360 degrees, it is equals to 38 degrees. 0.316 times 360 degrees, it is 114 degrees or 114 degrees. Okay, 263 times 360 degrees equals 95 degrees. 0.211 times 360 degrees, it is equals to 76 degrees. And of course, another 0.026 times 360 degrees, it is equals to 9 degrees. And for the total of, make it sure it is 360. Did you get it now? Okay, next step. You have to put right there the percentage. Okay, here's how to do it. Look at the computation at the bottom. Okay, so the percentage is equals to the relative frequency times 100. Okay, or as simply as move the decimal point into 2 from the left to right. Okay? Okay, there you go. As you can see, in the last column, we have there the answers. Guys, as simply as you have to multiply it into 100 or move the decimal point. Okay, the 0.026, now 2.6%. The 0.053 is now 5.3%. The 0.105 is now 10.5%. The 0.316 now 31.6%. The 0.263 now 26.3%. And the 0.211 now turned 21.1%. And the 0.026, okay, now turned 2.6% for a total of absolute 100%. Did you get it now? Okay, guys. I hope you're still with me. We still have a long way to go. And I hope that your energy is still intact. Okay, so pay attention. Okay, so this time, next step, we're going to make a frequency polygon. Okay, that will be our last task. But before we're going to make a frequency polygon or a Cartesian plane, we just have to get the midpoint. Okay, we'll be using the midpoint to make a frequency polygon. Okay, how to get the midpoint? Look at the bottom. Look at it. So guys, from 27 to 35, the middle number of that is 31, right? So let's just check. Why is it 31? Okay? So the interval is 9, right? So 27, 28, 29, 30, 31, 32, 33, 34, 35. Okay, so the middle number of that is what? 27, 28, 29, 30, 31. 31 is the middle number. So 31 is the midpoint. Did you get it? Very good. Let's proceed. Okay, guys, this time I'm going to show you and demonstrate on your screen how to make a frequency polygon using the Microsoft Excel. Alright, this time, guys, allow me to demonstrate how to make a frequency polygon using the Microsoft Excel. And I hope that you're going to follow me using your own laptops or personal computers if you have right there in your house, okay? Well, you can also go to the internet cafe. You can do this task right there if you don't have your own computer. Okay, so let's start it now. Okay, so guys, I'm shooting my computer right now. Okay, can you see it? Can you see that the arrow is moving? Okay, I want you to follow it, okay? Alright, so I'm going to click on the Insert tab. Can you see it? Okay, alright. I'll be clicking on Insert tab, and let me go to the sub tabs. There's a lot of options right there in the sub tabs. So I'll be clicking on Chart. And then right after that, I'll be clicking on Line right here. Okay. Click on OK. So it's now pulling up. You just have to wait a while. It took it so long. Okay, so as you can see, guys, there's a lot of lines right there, but guys, all we need is just one line. Okay, so to delete those other lines, we just have to delete the data that it's already right here. Okay, just give me one moment. Let me just delete this stops. Okay, there you go. Oh, I have to delete it all. Much better. Because I'm going to input all the data that we got right here. Okay, so here in the first column, guys, we're going to put all the midpoint distribution, or I'm sorry, the midpoint of the intervals. As you can see right here in the screen, okay, let me use my finger. Okay, right there. Okay, I just put it right here also, so that it's easy for you to look for the information or for the data. Okay, so 27, the interval 27 to 35, the midpoint of that is 31. 36 to 44, the midpoint of that is 40. It's colored red, okay? So it's for you to easily notice the midpoint, okay? So, let me start right here. 27, interval 27 to 35, 31. So let me put 31 right here, okay? Enter, and then next is 40. The midpoint is 40. Next is 49. Next is 58. Next is 67. And then 76. And then 85. There you go. Okay, are you still following me? Okay, that'll be great. Oh, let me just expand this one. Okay, so let's get back to the top. Okay, in the second column, in the first row. Now, okay, so we're starting right here. So we just have to input the frequency. Okay, here's the frequency, right? Okay, you can see my fingers moving right there. So I'm sure that you're following me. You know what I'm saying right here. Okay, so the frequency right here. Let me just use the mouse once again. Okay, the frequency right here is 1. Okay, let me put 1 right here. 1. Okay. Okay, there you go. We got 1 right here. And then next row, Okay, I should not use my mouse because there will be some kind of problem if I'm going to use my mouse. Okay, just to point right here. Okay, so next is what? Okay, 40. So the frequency of this is 8. Okay, let me put 8 right here. 8. Okay, next to that is what? 10. Okay, 10. Next is 12. The frequency of the interval 54 to 62. The midpoint is 58. So the frequency of that is 12. Next is 4. Okay, for the 76 is 2. Okay, and for the 85 is 1. There you go. Okay, since that we did putting all the data that we need or the numbers that we need to make a frequency polygon, let's click on X or exit. There you go. Wow, we have our frequency polygon right now. Okay, so it seems that it's not too clear for you to see it, so we can change the background of that. Okay, as you can see, well, you can do that also. You can also do this. Okay, yeah. All right, guys, congratulations, we did it. We already got our frequency polygon, but the problem is we don't know how to read it yet. We might not be able to interpret it yet because we don't know how to read between the lines. By the way, do you know how to read between the lines? Oh, you must have to because this is a statistics class. It's very important for you to know how to read between the lines. Okay, now, don't you know, guys, that there are 3 types of shapes of distribution? Number 1 of that is positive skewed. Majority of the data values falls to the left of the mean and cluster to the lower end of the distribution. Next is negative skewed. It looks like that, okay? Negative skewed, majority of the data values fall to the right to the end and cluster at the upper end of the distribution, as you can see. Number 3 is symmetrical. It sounds good. Well, anyway, symmetrical, the data values are evenly distributed on the both sides of the mean. Even if the skewed are equal, the sharpness of the peak is still in the measure of kurtosis. So it looks like that. By the way, guys, we also have 3 types of symmetrical line, okay? Or symmetrical shape. Number 1 of that is mesokurtic. Mesokurtic is what we call well-balanced, average, or normal. As you can see on your screen, it looks like that. And that is mesokurtic. Next is leptokurtic. It looks like that. It is more peak. Moreover, there are 2 types of leptokurtic. Number 1 is skewed to the right. So it means if it is skewed to the right, most of the respondents got low scores. Another one is skewed to the left. It means that most of the respondents got high scores. And the last one is platykurtic, or what we call hetero. Okay? It is a flat top curve. Okay? So it looks like that. Okay, guys, before we proceed, let me just do a little recap. Maybe some of you guys are confused about my discussion earlier about the shapes of distribution. Okay, let me just do a little recap. There are 3 types of shapes of distribution. Number 1 is positive skewed. Number 2 is negative is the negative skewed, and the third one is the symmetrical skewed. Okay, and symmetrical skewed have three types. Okay, the three types of symmetrical skewed. Number one is mesokurtic, or what we called, or mesokurtic, or what we call well balanced, average, or normal. Second symmetrical is what? Is leptokurtic. Okay? Leptokurtic is more peak. Okay? And the third one is platykurtic. Okay? That is the third type of symmetrical skewed. By the way, there are also two types of leptokurtic. Okay? What are the two types of leptokurtic? We got the skewed to the right. Okay, when it is skewed to the right, it means that most of the respondents got low score or scores. And when it's skewed to the left, most of the respondents got high scores. Do you get it now? Okay, so now we're going to interpret the data reading what's in the frequency polygon. So, guys, what is its skewness? Is it skewed to the left or skewed to the right? So it is skewed to the right. And it means that if it's skewed to the right, it means that most of the students or respondents got low scores. Did you get it now? Very good. Wow, that's the end of our discussion. We did it. We did it. We did it. Hooray. Thank you very much, guys, for attending my class. I'm so proud of you that you keep up on tuning into my lesson. Okay, so I want you to get ready and, of course, pull up your worksheets or your module once again, because I'll be leaving you some activity or evaluation. And for those who are attending my class online, well, you can do it on your you have to do it with your with Microsoft Word, and then you can attach the file to your email and send it to dowy1117@gmail.com. Evaluation. Classify each of the following as nominal, ordinal, interval, or ratio level of scale on the second column, and identify the type of data on the third column. Okay, there you go. Number one, the sales of McDonald's in each month. Number two, an employee ID number. Number three, the response of time of Nabunturan Fire Department. Number four, scores obtained by the students in English test. And number five, performance rating of teachers categorized as outstanding, very satisfactory, satisfactory, and unsatisfactory. Okay, and the next thing that you're going to do, you just have to organize the data that is right there. Okay, so this is a set of scores on an English test. The highest score of that is 90. Okay, the task that you'll be doing, you have to construct a frequency distribution table for 20 points. And you're going to make a frequency polygon using the Excel. I have shown you how to do it, okay? So that is what? 10 points. Okay. And last one is you're going to interpret the data, whether if it's skewed to the left or skewed to the right, and you just have to state the interpretation. So I think we're done already. Thank you very much, guys. Woo! Thank you once again. Hope to see you soon, guys. Thank you, thank you, thank you. Bye-bye. Wow.